Hello friends, welcome back to Smart Engineering Academy. Myself Amit, I am here with the Excel sheet. I am going to start a design of singly reinforced beam manually as well as in the Excel sheet. In the right side I am going to do it manually. The obtained values I am going to enter here. Finally I will just cross check the values between the two. So here is the question. They have been given spreadsheet for a design of simply supported singly reinforced beam. They have been given here simply supported singly reinforced beam subjected to UDL. Okay, that is the one thing. Some of the input data they have been given, that is UDL. The load is 10 kilonewton per meter. M20 grade, that is the grade of the concrete they have given, that is 20 Newton per mm square, that is M20 concrete. And Fe415 steel, take width of the support is 230 mm. Okay, I'll just draw a figure and I'll tell you all things. Okay, we'll change one thing. Let us take it as, instead of taking Fe415, I'll take it as Fe500 steel. That is, the beam is supported at the ends and the load is acting here. This is called a simply supported beam. There are many types of beams. I'll just tell you. One is cantilever beam, that is one end is fixed and other one is free. This is called as cantilever beam. If a beam is supported by the two support at the ends, this will be called as simply supported beam. So if it is continuous like this, okay, then it is called as continuous beam. And one more we can call it as an overhanging beam, that is one end is supported at the end, other end is not supported in the end, and some portion of the beam is overhanging. This type of beam is called as overhanging beam. But according to the question, they have been given simply supported beam. So at the ends the beam is supported at the ends and the load is acting upon the beam. So let us see in the question, what is the type of beam that is acting upon the beam? That is, they have been given UDL, uniformly distributed load. Okay, if in the simply supported beam, if I give like this, then it is called as concentrated load. But they have been given uniformly distributed load. That means it is represented like this. That is, the load is uniformly acting upon entire span of the beam, that is W. The value of uniformly distributed load they have been given 10 kilonewton per meter. Fine. So one thing we came to know, that is simply supported beam with uniformly distributed load. So what is the other data which has been given here is M20 grade. So while constructing the beams, they have been used, the grade of the concrete is M20. I think you are familiar with this thing. And the steel which is used here is with a grade of Fe500. Okay, take the width of the beam is 230 mm. So how will I take the width of the beam? Okay, in the 3D diagram in the previous lecture I had shown you, this will be the longitudinal section. If you take this as a 3D diagram, okay, this will be your longitudinal section. Okay, this part what I am scratching, this is the cross section. I am just drawing it like this. So this is the cross section. What they have given is, take the width of the support is 230 mm, the width of the beam is 230 mm. Okay, don't get confused. In the question they have been given width of the support. Okay, width of the support means, so this is the width of the support. Okay, what we call it as, this is the width support, this is called as support. Width of the support they have been given 230 mm. Okay, one thing you need to remember here is width of the support will be equal to width of the beam, because the beam is resting upon the section. Okay, width of the section will be equal to width of the beam. That is the one thing you need to remember here. Okay, just copy this thing, this is very important. In the question either they may give with the width of the beam directly, or sometimes they may get confused. Both the things are same, don't get confused. So one more thing I had missed out, I'll just add here. Clear span is equal to 8 meters. Okay, so now what is clear span? The span between here, from here to here. Okay, between the support is called as clear span. They have been given this as 8 meters. Okay, then what about from here to here, from the column center, the center of the support, if I take from here to here, okay, L center to center distance is equal to what, that we need to find out. Okay, so just remember L center to center and L clear. And one more thing, by using these two equations we are going to find the effective length. Okay, just remember this concept, that is enough. Now let us start doing the Excel. Okay, in your Excel sheet just write down the question like however you want. Okay, you just write down the clear span, width of the support like this, and clear span they have been given here in meters. So I am just writing here 8 and I am representing it in terms of meters. Okay, that is the 8 meters. Width of the support they have been given, that is 230, which is in mm. What is the grade of the concrete? 20. What is the grade of the steel? 415. If you want, you can write the units here, Newton per mm square units here. That is not an issue. So now tell me, what is the width of the beam? I told you. What is the width of the beam? Yeah, come on. Yes, width of the beam will be equal to width of the support. So I'll just press equal sign. Okay, I'll just press equal sign and I'll click upon this, that is width of the support, and I'll give enter. Okay, so I had got 230. Okay, this will be equal. In case in the question instead of giving 230, if they have been given 300, if I enter 300 here, automatically the value which is in width of the beam changes. So I'll just take what they have been given, that is 230. See, 230, this is automatic. Whatever the value you are going to change here, that is going to get changed automatically, because I had added some format. That is the beauty of the format, and that is the beauty of the Excel. Okay, now let us move on with some concepts. That is, what is the depth of the beam? The next tabulation what I have to do here is, what is the depth of the beam? Okay, for this I'll tell you one concept. I'll just write a cross section of a beam. Fine. Okay, this is a cross section of a beam. Okay, depth of the beam is overall depth of the beam. Okay, I'm just telling you, this is overall depth of the beam. Okay, this is the cross section. And what is this? This is longitudinal section, this is the cross section. The overall depth of the beam is this thing. That is one concept. The second concept is, if this is the overall depth of the beam, as I told, in the singly reinforced beams, I am going to give the steel in the bottommost portion only. Okay, then one more concept is called as small d. Small d means effective depth. Okay, effective depth. Effective depth is from the center of the steel, okay, from the center of the steel and from the top of the beam. This is effective depth. So this is overall depth and this is effective depth. Effective depth we are making you with the help of effective depth, and we are going to calculate many of the things. So these two things are very important. Now my next question is, how will you find the value of d and the value of small d? Okay, before finding the value of big D, I need to find the value of small d by using L by D ratio, which is given in IS 456 2000. So how to find, I'll tell you in detail. So just look at the things and be careful. See, I'll give you a suggestion. While learning this, you just open this video in your mobile and keep the laptop in front of you. Okay, just see the video, and automatically seeing the video you go and enter the values in your laptop so that you can learn very smartly. Fine, it's just a suggestion, you do like however you are comfortable. Okay, now according to IS 456 2000, so L by D ratio will be equal to 20. This is for simply supported beam. In case if it is cantilever beam, at that time L by D ratio would be 7. In case of continuous beam, L by D ratio would be 27. Okay, just remember these things. These things will be asked in the competitive examination. What is the L by D ratio of the cantilever beam? What is the L by D ratio of the continuous beam or simply supported beam? But in the question they have been given, they have been mentioned in our question, that is simply supported beam. So let us make use of L by D ratio is equal to 20. So if L by D ratio is equal to 20, then I told you we need to find D. D will become D is equal to L by 20. So what is the L? L is the clear span, 8. I need to take it is in mm. 8 into 1000 divided by 20. Okay, if you calculate this, you will get, how much you will get? You will get 400 mm. Okay, this I have to prove here. Okay, I'll just apply here. See here, for L by D ratio, I had written L by D ratio, which first what I have to do, I need to press equal sign, open a bracket. Okay, I need to L by 20. What is L? I need to go here 8. Okay, h5 means h, and this is 5. It is taking like this, into 1000, because I need to, this is in meters, I need to convert it into the mm. Okay, I'll just close the bracket, divided by 20. If I press enter, I am getting 400. Fine. If you want, you can pull like this and write it as mm, not an issue. 400. Okay, in case while doing, so what important here is, in case if they have given, I want to change a question. See, they have been given some other question telling length of the clear span is 10. If you change here, it has 10, automatically L by D ratio gets changes, everything gets changes. So that is the format what we are creating. So now I'll just give you, see, if I give 10, it is coming to be 500. So I'll give it as 8, automatically it is getting changed, that is 400. Now I got effective depth. From L by D ratio, I got effective depth, that is small d. Okay, so here I'll just write a figure. So this is overall depth, as I told you, steels are here. Effective depth is from center of the steel up to here. So we have got 400 here. So that is D is equal to 400. So then what is the value of capital D? I don't know, but I can imagine, sorry, I can assume it some value, so that it should be more than 400. Okay, see, the value of the capital D is more than the small d, so I'll just assume it 500. Okay, in the below steps we can see for the safe, we can check it for the safe. Now I'll just assume it as a 500. I'll come here and I'll write it as 500. So the next step is how to find the effective depth of the beam. So first of all, what is effective depth? I'll just go through the concept. So just have a look here. Assume cover, effective cover, diameter of the bar, effective depth, effective length. Okay, everything I will just tell in one figure. I'll just draw a figure. So this is the cross section of a beam. According to the single reinforcement, I am going to provide a bars here. Either it may given one layer. So if only the one layer, if the bars are provided, then it is called as one layer, and we can provide also one more layer. So this is two layers. If the bars are provided on the top, then it is called as doubly reinforced. Okay, don't get confused. in a singly reinforced beam, either it can be given single layer or double layer. Okay, I'll just take it as double layer only. So according to this, they have been given assumed cover. Cover is from here to here. Okay, this is clear cover. Okay, let us assume this as 20 mm. For beams, it can be assumed to be 20 mm. So then second one is effective cover. So what is effective cover? Okay, I'll just draw one singly reinforced section. So people will be a bit clear. If I draw two steel here, okay, you know overall depth of the beam, effective depth is from here to here. Fine. So clear cover means from here to here. This is clear cover, that is from steel bottom to here. So the effective cover is from center of the steel to the bottom. This is called as effective cover. I'll just draw on big figure so that it will be a bit clear. Okay, this is singly reinforced beam with single layer. This is effective depth. Clear cover is from here to here. It is clear cover. Okay, from here to here, from the center of the steel to the bottom, it is called as effective cover. So how will you find the effective cover? It is very simple. See, what I am telling is for single layer, effective cover is equal to, so you know this is clear cover, which is equal to clear cover plus dia of this bar, okay, dia of this bar divided by 2, so that you will get a distance from here to here, that is your effective cover. But what happens in this? Okay, in this, if I take the distance between these two bars, if I take the center position of this from here to here, it will be effective cover. So what is the formula for effective cover? It is very simple. So effective cover is equal to clear cover plus, okay, from here to here it is clear cover plus dia of this bar plus this distance is there, no, this distance, some distance, this distance divided by 2. So what is the distance? This distance, that is okay, this distance is equal to dia of the top bar. Okay, I'll just take it as d1. In this I can explain in a bit clear manner. So this is clear cover, fine, that is clear cover plus diameter of the bar. Okay, up to here I got a distance. Then what is my effective cover? Effective cover is from the center of these two bars up to here. This is called as effective cover. From, so I got a distance up to here, I need to take up to here for this effective cover, that is between these two. How will I find? So that this distance I am assuming, okay, this distance I am assuming is equal to dia of this bar. Okay, I'll just take it as a dia d1. This d1 is the dia of the bar. Okay, by that I'll get a effective cover. See, small d is the diameter of the bottom bar and the top d is the d1 is the diameter of the top bar. By this I can get a effective cover. Okay, I'll just add a values. Let us assume the clear cover is equal to 20 and diameter of the first bar. I'll assume it as, this also can be assumed, I'll just assume it as, that is d is equal to 20. Okay, 20 plus, what is this d1? That is the top bar, diameter of the top bar d1 is equal to 16. So 16 divided by 2, it will become 48 mm. I want to prove it in the Excel. So I am directly going into the Excel. So what is the, just be familiar with this concept. I am just writing it directly. What is the assumed cover? Assumed cover is 20. I am writing it as a 20. Fine. effective cover. For effective cover, I need to apply the formula. Before that, what I need to do? First layer, second layer. That is, see here, diameter of the bar add return. What is first layer? First layer means what you can see here. This is first layer. Second layer is this one. So what is the diameter of the bar in the first layer? I had assumed it as 20. I am just writing it as 20. This is an assumption. What is the diameter in the second layer? It is 16. Fine. So now in order to find the effective cover, I need to put a formula. I'll press equals, I'll open a bracket. So what is the formula? Clear cover plus, what is the D? This D itself. Okay, D1, that is first layer, plus, I'll just open the bracket, 16, that is this D, divided by 2. I'll just close the bracket. One more bracket. If I give enter, see 48 mm. I had been proved. So this is ready. Okay. So for some things, I will make it as a, I'll just give you a color which is yellow. I'll do it like this. Okay. I'll give some other color. It means that these values are flexible. That is, it is been given data, it can be changed. But L by D ratio, you should not change, and you cannot change because it is in the format state. But this is see here 8, it is not in the format state. If they have given some other question, you can directly change the value so that all the values which is present in the Excel is going to get changed. Okay. So this is flexible, this is not flexible, this is not flexible. Okay, fine. This is what you are giving. I'll just make it yellow color. Okay. This is what you are giving, this is what you are entering. Okay, that means these things are flexible. This should not touch. Okay, if I change, for example, I am going to change, instead of 20 I am giving 22. See, instead of 40 it is becoming 50. If I give it 18, again it is getting changed. Okay, so those values are not flexible. This should not be changed or this should not be touched. So I had made some marks, that's all. 80 whatever the thing, 20, and this is 16, that is 48 had been proved. So then the next step is I need to find the effective depth and effective length. First of all, I will tell you what is the difference between effective depth and effective length. So now how to find the effective depth and what is effective depth. So fine, you know this is a singly reinforced beam with 2 layers. So from here to here, this is the overall depth. What is the overall depth of the beam is 500, and I had found the effective cover. What is the value of effective cover? It is 48 mm. Fine. So from here to here, this is effective depth. So what is the value of effective depth? The effective depth is equal to total distance is 500 minus 48. This will become 452. Okay, so this is the concept. I'll just add here, again equals to, open the bracket. So what is the overall depth of the beam is 500. I'll click here, minus effective cover, close the bracket, and it will give the effective depth. Okay, just write, give it as mm. Okay, next is effective length. So I'll go through the concept of effective length. Okay, this is little tricky, just listen it very carefully, don't get confused. Fine, this is the beam. I told you this is the L clear span, and this is the center to center, that is LC. I'll just take it as LC, and this is L clear span. So then how to find the effective length of the span? So we know these two things, and how to find the effective length of the span is my question. So just forget about this thing, only clear length. So I'll directly give the formulas. L effective will equal to, there are two formulas. One is LC clear span plus effective depth, okay, or else clear span plus width of the beam, whichever is lesser, the lesser value I need to take into consideration. Fine. So let me find out. So what is the LC? Length of the clear span is 8 into 1000, because it is given in meter. I am just converting it to the mm, plus depth we have just found out, that is 452, or again same thing, clear is 8 plus 1000 plus what is the width of the beam? Width of the beam is 230, which is 230. So this is 8452 8230. So which one is minimum in these two things? So 8230 is minimum. So you need to make use of this thing. So the main question here is how to enter the value in the Excel sheet, so that, see, in some of the cases I may get the first value also minimum or either second value also minimum, whatever may be the case. But how to enter this Excel? Manually it is easy. You are going to calculate the two values and the minimum value you are going to take it directly. But in the case of Excel, what happens? Here plays a main role in applying the formula. This is very easy. I will just teach you. So as we know, we need to press equals. Okay. Then the code point is if you'll get here, just click here. If I need to take three things. Sorry, that is not if. I need to calculate. So what I wanted is the minimum of these two values, right? Which is the lesser value. The cheat code here is min, minimum of the two things. Okay. I'm just opening the bracket. I am writing the first thing, that is first condition. What is first condition? Clear span plus effective depth. What is the clear span? 8. I need to convert into the I'll just into 1000, right? I just close the bracket plus what is the effective depth? It is 452. I'm just closing the bracket and I need to give comma, then I'll again open the bracket and second condition. Okay, first condition is this thing, second condition is clear span plus W, right? What is the clear span? I'm just going here and clicking upon this and I'm converting it into Okay, I'll open one more bracket just for the safer side plus, see, bracket everything is same as you are going to apply in your scientific calculator. Use maximum brackets, minimum of this thing. Next, what is this? This is 230, that is width of the column, right? Sorry, width of the beam. What is the width of the beam? That is 230. I'm just closing the bracket. I'm giving enter. See, there is a shortage of brackets. Okay, if I press yes, it automatically takes. Okay, fine. Here I am loading one more brackets. Everything is same. I am giving it enter. See, I am getting